Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss permutations and combinations. In this chapter, we are going to discuss the concepts of exercise 7.4. In the previous class, we have discussed the concepts of exercise 7.3 as well the sums in the exercise 7.3. I hope you have understood the concepts of exercise 7.3 well. I hope you have learnt the sums in the exercise 7.3 well. Okay, my children. Now come to the concepts of exercise 7.4. Are you ready to listen the class? Right. See first one, combinations. In the previous class we have discussed about permutations. Now we discuss about combinations. What is meant by combination? Each of different selections made by taking some or all objects of a number of objects irrespective of their arrangements is called a combination. Okay, my children, this is a definition of a combination. To understand this definition well, let us take an example. List of, list of different combinations formed of three letters A, B, C taken two at a time. Suppose three letters are there in our hand. How many selections? Combinations means selections. In how many ways two letters can be selected? See here, AB, that is one selection. AC, that is another selection. BC is another selection. Only three combinations are made here. Yes or no, my children? In the permutations we got six. Yes or no? That is arrangements. But here only combination. Again, in the case of permutations, we wrote BA, CA and CB also. Understood this point, mentioned difference between permutations and combinations. Let us take another example. List of different combinations of four letters A, B, C, D taken two at a time. If we are taking only two letters, if we are selecting only two letters at a time from these four letters, so how many combinations are made? AB, AC, AD, BC, BD and CD. How many combinations are there? 1, 2, 3, 4, 5, 6. So total 6 combinations. Understood this point, my children? Combination means a selection of objects from number of objects. See here, second point. Difference between a permutation and a combination. Let us discuss here what is the difference between a permutation and a combination. In a combination, only selection is made, whereas in permutation, not only a selection is made, but also an arrangement in a definite order is considered. Understood this point, my children? Here, combination means only selection, but permutation means we have to select the objects and we have to arrange them in a definite order also. Understood this difference, my children? Right. Now come to this difference, my children, between permutations and combinations. Second difference. In a combination, ordering of the selected objects is immaterial, whereas in a permutation, the ordering is essential. In permutations, order of the objects is very important, whereas in the combination, order of the objects is not an important, immaterial. Understood this point, my dear children? To understand this point well, let us take an example. For example, AB and BA are same as combinations. Here we don't consider these two are different combinations. We consider this is only one combination. Only one combination. Okay, my children. But different as permutations. But in the case of permutations, these two are treated as two different permutations. Whereas in the case of combinations, these two are considered as only one combination. Understood this point, my children? Right. Now come to the difference between permutations and combinations. Third difference. Practically, to find the permutations of n different items taken or at a time, we first select r items from the n items and then arrange them. In the case of permutations, first we have to select r items. If we are finding the number of permutations of different items, different objects are there, and we have to arrange 6 objects. By taking 6 objects, we have to arrange them. Then first we have to select r items from the n items, and then we arrange them. Then we arrange that r objects. Yes or no, my children? So usually the number of permutations exceeds the number of combinations. Okay, my children, understood? The number of permutations is more than the number of combinations. Next difference, fourth one. Each combination corresponds to many permutations. Okay, my children. For example, the 6 permutations ABC, ACB, BCA, BAC, CBA and CAB. These are all considered as different permutations, different arrangements. Okay, my children. But in the case of combinations, this corresponds to the same combination ABC. If you observe here also 3 letters, the same letters ABC, 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 ABC. So only one combination. But in the case of permutations, we considered 6 different permutations. But in the case of combinations, we treat it as only one combination. Understood the difference between the permutations and combinations, my dear children? Right. Now come to this point, my dear children. Remark. Generally, we use the word arrangements for permutations and the word selections for combinations. Okay, my dear children. In the problems, generally we use the word arrangements for permutations and we use the word selections for combinations. Okay, my children. Permutations and combinations are mathematical words. These are general words. Arrangements and selections. Okay, my children. Understood this point? Right. Now come to notation. The number of all combinations of n objects taken or at a time. Suppose n objects are there in our hand and we have to select r objects. We have to select r objects. Then it is generally denoted by CNR in the brackets. Okay, so this is not a point. Don't be confused. This is not a point in the coordinate system. In the Cartesian plane, this is not point. This does not denote point in the Cartesian system. This is a combination of n objects taken or at a time, or NCR. Same as in the case of NPR. As understood this point, my children, you should not write these 3 letters in the same line. In this like this only. For this number, you have to write as a subscript, capital letter C. For this capital letter C, we have to write small r as a subscript. Okay, my children. This is a correct notation. Okay, my children. Or NCR like this. Open brackets, above N and down R. All these 3 notations denote the same combinations of n objects taken or at a time. Okay, my children. But in general, we use this notation. In this textbook, we use this notation. Thus, NCR or NCR is equal to number of ways of selecting R objects from n objects. Okay, my children. So, this is the meaning of NCR. NCR means the number of ways of selecting R objects from n objects. Okay, my children, understood this point. Clearly, NCR is defined only when n and r are non-negative integers such that 0 less than or equal to or less than or equal to n. Okay, my children. See, this definition is defined when these two n and r should be non-negative integers and moreover 0 less than or equal to or less than or equal to n. This condition also should be satisfied. Okay, my children. Right. Now come to the theorem. Theorem is nothing but formula to find the number of combinations of n different objects taken or at a time. See the formula, the number of all combinations of n distinct objects taken or at a time is given by NCR is equal to n factorial by r factorial into n minus r factorial. We use this formula to find the number of combinations of n objects, combinations of n different objects taken or at a time. Okay, my children, remember this formula. NCR is equal to n factorial by r factorial into n minus r factorial. Okay, my children, understood this point? Right. Now come to this point, my children, properties of NCR or NCR. Okay, my children, here we are discussing these 5 properties of NCR. See, first property for 0 less than or equal to or less than or equal to n, we have NCR is equal to NC n minus r. Okay, my children, NCR is equal to NC, difference between the two numbers, NCR is equal to NC n minus r. Okay, my children, the value of this equal to the value of this number. Okay, my children, right. Come to this second property. If NCR is equal to NCS, then R is equal to S. These two numbers may be equal. Otherwise, N is equal to R plus S. This is another property. Okay, my children, understood this property. Next, third property. NCR plus NCR minus 1 is equal to N plus 1 CR. Okay, my children, right. Now come to the fourth property. Let N and R be non-negative integers such that 1 less than or equal to or less than or equal to n. Then NCR is equal to n by r, n minus 1 c r minus 1. Okay, my children. This is another property of NCR. And the last one, if 1 less than or equal to or less than or equal to n, then n into n minus 1 c r minus 1 is equal to n minus r plus 1 c r minus 1. These are all properties of NCR. Okay, my children. According to the question, we use these properties to solve the question. Okay, my children. So these are the concepts of exercise 7.4. All of you go through the textbook once, my dear children, from page number 149, 148, page number 148, 149, page number 150, 151 and 152 and 153. Once go through this textbook, the pages in the textbook from 148 to 153. Once go through these pages in the textbook, my dear children, we start the sums. Okay, my dear children, right.